In this video, we are to draw the shear force in the bending moments diagram for the cantilever beam below. First of all, we need to calculate our support reactions. So this side is A, this is a fixed support, and this side is A, and this side is B. Fixed support has three reactions. So a vertical reaction, we call it VA. A horizontal reaction, we can call it HA. And a moment, so we can take the moment in the clockwise direction and we'll call it MA. We have to make use of our equilibrium equations. So sum of moments about point A is equal to 0. And taking moments about point A, 25. Let's take clockwise moments to be positive. So 25 kilonewton will cause a clockwise moment. It's going to be positive 25 times the perpendicular distance to where I'm taking the moment, which is 7. There's already an existing moment here called MA, and it's moving in the clockwise direction, so it's going to be plus MA is equal to 0. We will make MA the subject. So MA will be equal to negative 175 kilonewton meter. Now let's find VA. To find VA, we sum vertical forces and equate it to 0. Let's take upward forces to be positive. VA is moving up, so it's to be positive VA. 25 kilonewton is coming down, so it will be minus 25 kilonewton. These are the only vertical forces, and we equate it to 0. So VA will give us 25 kilonewton. Now let's find HA. So we sum horizontal forces and we equate it to 0. Let's take forces moving in to the right direction as positive. So HA is positive, and it will be equal to 0 because that's the only horizontal force there. Good. We are done calculating the support reactions. So let's do the calculations for the shear force. So the shear force is the sum of the vertical forces. So let's deal with point A. So we'll calculate two shear forces. So shear forces at A. So shear force at A prime will be equal to 0. So the first one will always start from 0. And now come to shear force at A itself to be equal to the previous one, which is 0. Then we'll factor in the vertical force, which is at E. So VA is moving in the upwards direction. It's moving up, so it's going to be plus 25. And this is going to give me 25 kilonewton. Now let's calculate for the shear force at B. So we'll calculate two shear forces. Shear force at B prime is equal to the previous one, which is 25 kilonewton. Then we'll calculate for shear force at B. We'll pick the previous one, which is 25. Then we'll factor in the vertical force acting at B. So it's moving the downwards direction, so it is negative. So it will be minus 25. And this will give me 0. So that's the calculation for the shear force. So we can draw our shear force diagram. So we can call this place A. We can call this place B. So shear force at A prime was 0. So here is 0. Shear force at A again is 25. So plot 25 kilonewton. And we'll connect the two. Shear force at B prime is 25, so it will be on the same line. So at B, 25. Connect using a straight line. And shear force at B is 0. So we'll move from here to 0. So this is the shear force diagram, and it is all positive. Now let's do the calculations for the bending moments. So bending moments. bending moment at A. Unlike the shear force, we'll calculate only one for the bending moment. So bending moment at A. So let's take let's take the bending moment to our left. So it will be negative because it's moving in the anti-clockwise direction. So we'll call this BMA. It's moving in the anti-clockwise, so minus BMA. There's a moment here called MA moving in the clockwise direction, so it's going to be plus MA. Everything here is equal to 0. So when we make BMA the subject, BMA will be equal to MA. But we've already found MA, and that's negative 175. So negative 175 kilonewton meter. That's the bending moment at A. Now let's calculate for the bending moment at B. So we can pick our right. So because I'm picking my right, I'll take moment to my right. And we'll call this BMB. So it's moving in the clockwise direction. BMB is positive. So that's the only moment there because we are taking moments about where we made the cut. So there's no existing force again. That will cause a moment. So BMB is equal to 0. So we are done with the calculation for the bending moment. We can draw our bending moment diagram. So A and B. Bending moment at A, negative 175. So plot negative 175 kilonewton meter. So connect the two. So this negative 175. Then bending moment at B is 0. So we'll move to 0. So this is the bending moment diagram for the cantilever being shown, and it's negative. So thank you for watching this video.